Let's look at physics JAMB question. So this is basically part 2 of JAMB in 2026 examination preparation class. Question number 1, we have the wavelength of a wave traveling with a velocity of 420 meters per second is 42 meters. What is its period? Now the first thing we must do whenever we come across a calculation problem in physics is to take down the correct parameters given. So in the parameters we have the wavelength of a wave traveling with a velocity. So the velocity v is given as 420 meters per second, and the wavelength is given as 42. So the wavelength lambda, we use lambda to represent wavelength, is given as 42 meters. So now the question is, what is the period? Period t is equal to unknown. So you are required to determine the period of the wave. So the relationship that connects these three parameters is v is equal to wavelength over period. V is equal to wavelength over period. The period was required, so we are to make t the subject of the relation or of the formula. So making t the subject here, we are going to obtain that t period is equal to wavelength over velocity. Wavelength over velocity. So we can substitute the parameters. Period t is equal to wavelength is given as 42 divided by velocity, which is 420. So this gives 0.1 seconds. The unit of period is in seconds. So the correct option on the board is option B, 0.1 seconds. Let's consider the next question. The velocity of sound in air is at 16 degrees Celsius, is 340 meters per second. What will it be when the pressure is doubled and its temperature raises to 270 degrees Celsius? So options are given below on the board. Now before we can solve this, we have to state the law that governs the calculation on the board. And this law is called the Newton's Laplace law, which states that the speed of sound in a gas is directly proportional to the square root of its absolute temperature, and it is independent of the pressure. So from that relationship, from the law, we establish this relationship where we can say that the speed v is directly proportional to the square root of its absolute temperature. So from here we have v1 over v2 is equal to square root of t1 over square root of t2. Alright, so the next thing we have to obtain is to pick the correct parameters from the question given. So in the question we have t1, and t1 is equal to, t1 is given as 16 degrees Celsius. 16 degrees Celsius. Now note, the parameter is given in degrees Celsius. We must convert it to the standard temperature, which is in Kelvin. So converting to Kelvin, we add 273 to it. So we are going to obtain 289 Kelvin. So for T2 on the board is given as 127 degrees Celsius. To convert this to Kelvin, it becomes 127 degrees Celsius plus 273, which gives 400 Kelvin. Again, the velocity, initial velocity is given as 340 meters per second, 340 meters per second, and V2 is what we are required to calculate. So at this point, the next thing is making V2 the subject of the formula from this relationship. So to make V2 the subject, V2 is equal to V1 times root T2 all divided by root T1. So we are going to use the relationship to get the value for V2. We have that V2 is equal to, V1 is given as 340 times square root of T2, and T2 is given as 400 square root of 400, all divided by square root of T1, which is 289 square root of 289. Alright, so from there we are going to obtain 340 times square root of 400 gives 20, and the square root of 289 gives 17. We have 400 meters per second, and the correct option on the board is option D, 400 meters per second. The question on the board says, during a thunderstorm, the sound is heard over a long time. The phenomenon is referred as dash. Option A, refraction of sound, B, reverberation, C, superposition, and D, diffraction of sound. Now, during thunderstorm, the sound of the wave does not stop immediately. Instead, it continues for some time. This happens because the sound waves are reflected repeatedly by clouds, building, mountain, and other objects before finally drying out. So, the persistence of the sound after the source has stopped is what we call reverberation. So, the correct option on the board is option B, reverberation. In comparing the camera and the human eye, the speed of the camera functions as option A, iris, B, pupil, C, cornea, and D, retina. In a camera, the film or the sensor is where the image is finally formed, but in the human eye, retina is where the image is formed. Take note of this concept. So let's look at the options on the board. The first is the iris, it controls the light entering into the eye, and the second is the pupil, it is the opening that allows light in. So the third is cornea, which helps in the refraction of light. It helps in the refraction of light. So the correct option is retina. An object 4 centimeters high is placed 15 centimeters from a concave mirror of focal length 5 centimeters. The size of the image is, options are given below. So the first thing we must obtain in this question is to write down the correct parameters. So the correct parameters on the board, we have an object 4 centimeters high is placed 15 centimeters from a concave mirror. So let's say that, so for the question, object distance let's call it U, is equal to 15 centimeters, and the focal length F is equal to 5 centimeters. So we are going to apply the mirror formula to determine the image distance. So image distance V is unknown. To determine the image distance, let us use the mirror formula. And the mirror formula is given as is given as 1 over f from these given parameters is equal to 1 over u plus 1 over v. So we are making 1 over v the subject of a relation, and 1 over v is equal to 1 over f minus 1 over u. Alright, so you can substitute the values. 1 over f is 1 over f is 5 minus 1 over 15. 1 over 15. The absolute denominator is 15. 15 divided by 5 is 3, and 3 times this is 3, minus 15 divided by itself is 1, and 1 times this is 1. So we have 2 over 15. 2 over 15 is equal to 1 over v. Take note of this concept. So at this point, 1 over v is equal to 2 over 5. So if 1 over v is equal to 2 over 5, then the reciprocal of this, reciprocal of the object distance is given as 2 over 5. So the object distance itself, which is v will equal to, this is over 15, beg your pardon. So we have 15 over 2, which is equal to 7.5 centimeters. So now we have determined the value for the image distance. How do we get the magnification? Magnification is equal to v over u, which is the image distance divided by the object distance. So the image distance is given as 7.5 centimeters divided by, while the object distance from the question was given as 15. So we have 15 in centimeters, so this gives 0.5 cm. M is equal to 0.5 centimeters. So again, we have to apply another formula for magnification. Magnification is also given as image height magnification M is equal to image height image height divided by the object height, image height over the object height. Let's consider the question again. An object 4 centimeters high. So the object height is given as, object height H0 is given as 4 centimeters on the board, 4 cm on the board, and the image height Hi is what is required. Magnification is given as 0.5. So we are going to make the image height the subject of the formula from this problem. So from here we have that magnification M is equal to image height over object height. Making the image height the subject because we were required to calculate the image height from the question. The size of the image is, alright, so from this point we have Hi is equal to magnification times object height, which is equal to magnification is given as 0.5 times 4, which equals 2 centimeters. So the correct answer is 2 centimeters, and the correct option on the board is option D, 2 centimeters. The question says, an object is embedded in a block of ice 10 centimeters below the plane surface. If the refraction index of the ice is 1.50, the apparent depth of the object below the surface is option A 6.67 centimeters, option B 7.63 centimeters, option C 7.50 centimeters, and option D 2.50 centimeters. So the first thing we have to obtain is to take down the correct parameters. Now in the question we have 10 centimeters below the plane surface. That is the real depth of the object. So real depth is equal to 10. If the refraction index of the ice is 1.50, now refraction index n is equal to 1.50. The apparent depth of the object below the surface is apparent depth. The apparent depth is equal to unknown. Now the relationship between these three parameters on the board is that the refraction index n is equal to refraction index is equal to read depth divided by apparent depth. Read depth over apparent depth. This is the formula. But you are required to determine the apparent depth on the board. So making the apparent depth the solved depth, apparent depth will equal to read depth divided by refraction index. So we can substitute the values. So read depth is equal to 10 divided by the refraction index is given as 1.50. So 6.67 centimeters. So the correct answer is 6.67 centimeters, and the correct option on the board is option A. Which of the following is used for the correctness of short-sightedness? Option A, concave lens, B, concave mirror, C, convex mirror, and D, convex lens. Let us examine each of the respective options, starting from the last one. So the last is convex lens. We use convex lens to correct long-sightedness. So the next is C, option C, convex mirror. Convex mirror is not used for correctness of eye. Yes. B, convex mirror, it is not also used. Concave mirror rather, it is not also used for eye correctness. And option A, concave lens. So concave lens is the correct option. It is used to correct short-sightedness. So take note of this. Option A is the correct option. We don't use this one for eye correctness. We don't use this for eye correction. This is used for eye correction rather, but it is for long-sightedness. Take note of this. So the correct option is short-sightedness, concave lens. Two inductors of inductance 5 Henry and 15 Henry are connected in series, and a current of 5 amperes flows through them. The two energies stored in the inductance is, options are given below. Now the first thing we have to do is state down the correct parameters before using the formula for inductance. Current I is given as 5 amperes. Two inductors of inductance 5 Henry and 15 Henry. So two inductors are given in series, 5 Henry and 15 Henry respectively. So we are going to apply the formula for energy stored in an inductor. And energy stored in an inductor is given as 1/2 times L times I, where L is the inductance and it is given in Henries. I is the current given in ampere. But before we can determine the value for this, for the energy stored in an inductor, let us determine total inductance in series. So total inductance in series is given as, there are two inductors. So we have total, L total is equal to 5 Henry plus, when it is in series, we add directly. So 5 Henry plus 15 Henry, that is equivalent to 20 Henry. So at this point, we can substitute this into the energy stored formula. So energy stored, E, is equal to 1 over 2 times total inductance in series is given as 20 Henry times the current is given as 5. So this is equivalent to 1 times 20 times 5 all divided by 2. So 2 goes into 20 10 times, and we are left with 1 times 10 times 5. So the energy stored is equal to 1 times 10 is 10 and 10 times 5 is 50 joules. So the correct option on the board is 50 joules, which is option B. Let's move over to the next question. A ground state energy of hydrogen atom is 5.44 exponential negative 19 joules. If an electron drops from zero energy to ground state, calculate the frequency of emitted radiation. Options are given below. Now, given in parentheses that the Planck constant is 6.63 exponential negative 34 joules seconds. Okay, this is a photoelectric effect question in physics. Now, from the question, energy that was given was, so the ground state energy is basically the initial energy given, whereas the excited state energy is the final state energy given. Alright, the first thing we have to obtain is to write down the correct parameters. Now, in the question, we have the